gentleman with you, Milian Wolff from KDAB and KDE, who's going to talk to us about optimizing Qt applications.
Yeah, welcome everyone. I hope this is loud enough. Can everyone hear me? Yeah? Fine? Okay. Cool. So I think this room is full because you write C++ in Qt for a reason, right? I mean, we do want to have well-performing applications. So how do we optimize those applications? This talk, I'll show a couple of so-called antipatterns I've seen crop up in a lot of Qt applications I looked at. So the first question is always like, how do you optimize applications? So question to you, what is the first step? What is it that you do? Anyone? Yes, profile, exactly. And not only you profile, you also benchmark. And that's what I did for all of the examples I'm going to show. Here on this address on GitHub, I pushed a couple of Qt benchmarks that compare essentially two ways of how to solve a given problem. And then I'll show, I compare between them, and that way I can justifiably say, this is what you should be doing because it's just as easy, but much faster. Okay, so what do you think will happen when you profile Qt applications, and what will make Qt applications slower than they need to be? Anyone can guess? Like, shout anything? Yeah, I heard it already. It's malloc. It's heap allocations. That's what brings most Qt applications to their knees. It's temporary allocations, it's unneeded allocations, and there are many tools out there with which you can find those issues. And the second issues are related to cache misses. Those is what you should optimize for. If you wonder how to do that, find a good tooling to profile your applications. Heap track, vtune, perf, whatever, they all find these issues. Because when you just look at code and try to guesstimate how fast or slow something is going to be, you'll do it wrong. Because these numbers you have to know by your heart, and you have to know where they happen and where not, because otherwise you can easily misjudge by multiple orders of magnitude how slow a given code will be or not. For example, you often hear, yeah, of course I need to do heap allocation so I can prevent expensive copies, right? But if something is already an order of magnitude faster to copy around, if you can minimize copying, maybe using C++11 move semantics, then you don't have these issues. Just allocating tons and tons of stuff, even temporarily, that will kill you because it's so much slower than the simple mem copy, right? And then if you have a cache miss, this lower bar is what happens when you go to the main memory to run. Otherwise, a normal instruction that's in this order of magnitude, right? A couple of half nanoseconds or something. So another thing that I want to mention is people keep saying like, yeah, before you optimize stuff, or when you show code like I'm about to show, that's all premature optimization. This is not worth it, right? Don't do it. It's true, you should certainly profile and find issues where you can fix stuff and get the most bang for the buck. But oftentimes when you write new code, what you introduce is the so-called death by 1,000 cuts, the premature pessimization. So when you have two ways of writing exactly the same code, and one way is much faster than the other, and it's not harder to do one or the other, then please, please do take the faster alternative. Okay, with that said, I'll cover a bunch of examples in this talk now. So it's about how you use qstring, most of the time you abuse it, how to use Qt containers, how to deal with mutexes for thread synchronization and these kind of things. And then there's little tricks about Datetime and Qt. Maybe it's useful for you, I hope so. I could have easily extended this talk for multiple hours, so maybe next year there will be part 2. So let's start. What's wrong with this code? Can anyone guess again? What's wrong? There's an implicit conversion, exactly. Please shout in, right? Don't wait for me to call it. Here we have a function returning a qstring. And whenever you call this function, this string literal, this easy-looking code will at runtime be converted to a qstring. So that already means at runtime a UTF-8 to UTF-16 conversion. And then additionally, a buffer will be allocated, a qstring buffer will be allocated and then returned. So imagine calling that in a tight loop. It will bring your performance to the knees because of the temporary allocations. So how do you do it better? You simply wrap it in a qstring literal. It's as simple as that. When you do that, it gets converted at compile time. There is no runtime buffer allocation whatsoever, and that's as fast as it gets. If you happen to use Qt4, poor you, please use Qt5. Otherwise, do something like static const qstring equals whatever, and then return that so you don't pay the price every time, right? But Qt5 makes it much simpler and safe. Okay, what's the problem here? It's not that hard, really. I mean, it's probably, again, an allocation, right? This is what I'm hating about. Again, these two places here, they have implicit conversions. Both of these look very simple. Most of you probably write this code because it's so much simpler, right? But if you do this in a tight loop, like imagine lexing or parsing some string, maybe you should use qbyte array in the first place. But anyways, let's assume you use qstring. This will, again, allocate temporary buffers again and again and again, and it's going to be super, super slow. So what do you do again? You wrap it. Here I'm not using qstring literal, I'm instead using qlatin1string. When do you use one or the other? Either you watch Thiago's talk thing from last year about qstring and its internals, or otherwise you go by the rule of thumb. If there's a function overload taking a qlatin1string, use that one, otherwise qstring literal. Or if you share stuff, yeah. Now this looks really, really nasty, right? It's so many places where you can do something wrong. And that's why Qt comes with the capability to error out at compile time when you would otherwise incur these temporary allocations, these hidden implicit conversions between stuff at runtime. So I really, really hope that all of you compile your libraries, applications, whatever you're working on, with these kind of defined set in your build system in a central location. Because then you will find all of these nasty issues I just showed at compile time. And then you can wrap it with qlatin1string, qstring literal, whatever, and you don't pay the price anywhere, right? Also, by the way, QUL has similar issues otherwise. Also from the functionality point of view, that's very debatable whether you want implicit conversions from a string to a URL. Okay, that said, what's wrong here? It is, again, allocations, exactly. And this, imagine it happening again and again. In the worst case, I can't say it will always happen, but in the worst case, what is happening here is that you will have an allocation for every appending operation here. And Qt, again, has the ability to do better than that. What you have to do is leverage the qstringbuilder. So definitely, again, set the compile flag for your application, and then join the lines, have one long append operation. Or maybe use qtextstream and then stream stuff in, because that internally also has a buffer it can reuse, and that's probably going to be more efficient. And this one's actually just as easy to read as the slide before, right? So, what's wrong here? This is a simple function. I want to compare two strings, but I want to compare at the given offset into the bigger haystack, right? So what do? I get the mid at where I want to compare, and then I just do it, right? It's super simple Qt code. I've written that in my history as well. What can you do better than that? Yes, I think I heard it already. It's reffing. QString, this call here with .mid, it will essentially return a substring from that position at that offset until the end of the haystack, and it will allocate a new buffer every time you call that. Instead, if you use qstring ref and mid ref, you won't have any allocation whatsoever. And this is again going to be much, much faster, just because you can save these kind of temporary allocations, right? So one slide I put up explicitly because I think people keep misusing qstring. you have to be aware that qstring internally converts your data to UTF-16. Oftentimes, that's not what you need. Qstring is perfect if you then want to display these contents to the user on the screen. At that point, at the latest, you need to have this kind of conversion, right? That's perfectly fine. But wherever else, maybe you have some internal data stream you are parsing and you know the keywords in there are all Latin 1 or UTF-8 or whatever, and you don't want to show them to your users, maybe qbyte array is the best choice, because in memory usage will be half as large. It's just whatever you pass in, right? And maybe even you want to use std_string, because std_string has a small string optimization, which can be even faster than both of the other alternatives, right? But then again, this is the kind of optimizations where you have to actually look at the profiler, whether that makes sense for you or not. But don't use qstring everywhere just because there's qstring. Think about it, what you want to do, right? Now, Qt containers. What's wrong here? Hint, it's again related to allocations. No, it's not the alignment. That's perfectly fine. It's not unsafe code. It's just slow code. The issue here is that this struct is larger than a void star. So every time you append something to this list, the node will be allocated on the heap, on the free store. So if you have a list of thousands of elements and you just append at the end, which is what you do 99% of the cases, I'm assuming, then you will allocate each and every element on the heap, and you waste a lot of memory. You have allocations that cost a lot of time. So probably this is not what you want to do. In my opinion, by default, you should always use qvector. And only if the profiler tells you whatever you're doing with the container is slow, then maybe try out qlist, and if you're very, very lucky, it may be faster, but I doubt it in most of the time, right? What can you do even better than that, though? Because this is probably already faster than what we have seen. But if you additionally say, this type I'm declaring is movable, you have to look at the documentation, wrap your head around what this actually means. Most of the time, it is safe to declare your type as movable as long as you don't have a back pointer. You add this one line and magically all your vectors will become even faster because internally they can simply mem move stuff around instead of actually copying, calling constructors and destructors and things like that. So look in your code, try to add these things. It's going to make it faster. Now, I really like this example. It's a bit more code, but in principle, it's the same stuff we've seen before. Up here, I'm just defining a class with a very common API, right? I'm returning a container by value. That's perfectly fine. Most of the Qt API is doing that. It's copy on write, right? So this is fast. It's cool. And then down here, I call it, and I call .last or .begin maybe. So what's wrong with this code? You could return a const reference. I would strongly recommend against doing that, because think about this being a stable API. Maybe you want to change the internals eventually. That maybe it makes sense, but there's a better way most of the time. It goes in the right direction though, because here we return by value and we call a non-const overload here. I mean, there's actually a const overload of last, but by default compilers pick the non-const because this is what you return here, even though you don't mutate it at all. The non-const.last will actually detach and copy your list at runtime whenever you do this. Nasty, right? So be explicit about what you're doing. In Qt 5.6, Sergio, a colleague of mine, added const last for that purpose because he's seen these issues crop up in KDE software, and that's how he fixes it, right? There's an explicit do the const stuff. Don't care about whatever runtime issues might happen. That's never going to detach. Okay, that was about the sequential containers. Now let's look at the associative containers. What's wrong with this example? Why do I say this is bad? It's a map of a pointer to something else, right? I don't care what it is, but it's about pointers. Sorting, essentially, yes, exactly. QMap sorts stuff. Can you sort vectors? Can you sort pointers with any meaning? Does it make sense to keep pointer addresses sorted? Probably not, right? So what you actually want most of the time is a Q hash. And trust me, I've seen this happen so many times. You don't want that usually. Speaking of QHash though, once you start using it for proper value types, which you hopefully use most of the time, you see people abusing qstring again in many places. Like, you need to give a QHash overload, right? So how do you do that? Oftentimes people think like, oh yeah, there's a toString, I simply hash the toString and that's fine. Again, heap allocations, this will kill your performance of the hash. Because maybe this is going to be called millions of times. When you have millions, in this case even millions times 2 string allocations, it simply kills the performance. What do you do instead? Use either a boost hash combine or maybe std hash combine in std17. Or in Qt 5.5 or 6, I'm not sure, there's this private API which you can abuse. Or simply copy out what they do internally. It's essentially 2 lines of code. It's not hard. Google for these things, use that. Implement your QHash properly. Then again, I've seen many people misusing the API to iterate over these associative containers in Qt. So what you want to do here is get both the key and the value in a loop. And what they do is then they for each over the keys, and then they use key and value, right? And do a lookup for the value. This is super slow. Because not only will you have a temporary queue list allocation for all the keys, which may again involve heap allocations for every key element, you will also need to do another random lookup for every iteration of the loop. So instead, be explicit, use a for from begin and end of the container, much better performance. Even nicer if you're using std containers, which hopefully you do in many places of your code, you can use simply a range-based for because it has a begin first and second for key and value. Just as fast, probably faster, and much terser code. Okay, threading. What's the issue here? People think that just because QMutex has both the ability to be used as a recursive and a non-recursive mutex, that both are equally fast. That's not the case. People use recursive because it's so simple and they prevent deadlocks under certain conditions. It's true, it's simple, but it's also much slower, about a factor of 2 according to my benchmarks. So instead, you should restructure your code to have the public API always grab the QMutex, use a non-recursive mutex, and then delegate to actual implementations that are private and cannot be called from the outside. And in these functions, you don't care about the lock. You assume that, okay, once I'm called here, I know that the lock is held, and you cannot deadlock in here. If you only call locked functions from them, it's all fine. Okay, datetime. People measure stuff, or they grab the current datetime often. If you do that, oftentimes, especially on Linux platforms, you'll incur a huge penalty. Because internally, this will set the current Timezone configuration, which requires I/O and syscalls. It's easily orders of magnitude faster to instead work with UTC timezone. And only again, once you display dates to your user, you want to use whatever he has configured for the proper time zone he's using, right? At that point, you need the conversion. But for these kind of measurements, this is much faster, about 10 times or 20 times even. What can you do even better is use the proper class that is meant for that purpose, QLabs timer. Just use it. It's even simpler code, and it's again about 4 times as fast as the previous slide. Okay, and then I think I'm getting to the end of QtWS usage. Who of you has written code like this, right? I mean, you iterate over all the contents of a directory. And what you do is you get the entry list, and then maybe you want to figure out, is the entry actually a directory or a file, and then dispatch to subsequent functions. I've seen this pattern a lot. I wrote it myself a lot as well. But what happens here is that for every entry, you need to stat again to figure out the information about this file. Instead, use QtWS entry info list. That simply returns you the qfile info directly, which, by the way, is been done by entry list as well, so you don't pay any additional price there. And you don't need the additional studs and stuff like that here to figure out whether something is a file or directory. We knew that already. This can easily be 100 times faster or something like that. So again, if you have questions or if you question what I've been saying here, please take a look at my benchmarks, run them yourself, see for yourself, compare what is faster, what is simpler. And I can also only recommend reading the blog entry by my colleague Sergio Martins about his Clazy static code analyzer, which will find already many of these patterns, and we will improve it in the future, so that you can simply run it and it warns you about all of these performance issues in your code base. And looking forward with the Clang compatibility and features it gives us, we can even say, fix it and it will rewrite your code to the fast alternative and it will still work. And then hopefully no one will blame you for spending time on making code faster. So with that, thanks. Questions? Why is the QstringBuilder macro not enabled by default? I think it is enabled by default, but you would have to use, let's go back again. Here. Instead, you would need to use the % sign instead of plus. And that's because in some places you need to use the explicit conversion to qstring. So you may need to adapt your code when you add this macro. Backwards compatibility reasons, essentially.
Talk about the when using qstringbuilder or when using qlatin. Can you explain that?
Okay, the question is when to use qlatin one string and when to use qstring literal. I can only recommend watching Thiago's talk on qstring from last year. It's available on YouTube. He goes into very much detail in that regard. My rule of thumb is whenever you have a function and you call it and it has an overload taking a qlatin one string, then use that one. Okay, I think we're done, right? Cool, thanks.
Thank you very much.